In this video, we will review the data types available within the Java programming language. You should already have had exposure to these data types in the VTC course Java 7 Language Basics, so we will quickly be reviewing them. First, we must distinguish data types in Java. There are two types of data types in Java: primitive data types and class object types. A Java primitive type is predefined by the language and is named by a reserved keyword. Primitive values do not share state with other primitive values. The 8 primitive data types supported by the Java programming language are byte, short, int, long, float, double, char, and boolean. We know that byte, short, int, and long are integers. Float and double are single precision floating points. Char is a Unicode character, and boolean is 1 bit of information. There are 2 good reasons to use primitives instead of objects where possible. Number 1 is clarity. By using a primitive, you are making it clear that a null value is not appropriate. Number 2 is performance. Using primitives is often much faster. Okay, let's take a look at Java class object types. As you can see here, when an object is required to represent the primitive type and hence plug into the object hierarchy, we can use these object types. The wrapper classes are used extensively with collection classes in the Java util package and with classes in the reflection package. Here we have some primitive data types represented as objects in Java: byte, short, integer, long, float, double, character, and boolean. Here we have our class types that have not been initialized or given any value. We must be careful to always initialize object types to prevent null pointer exceptions in our programs. There are 3 different ways to initialize our objects: using a string, a primitive type, or the method value of. Let me demonstrate this. Allocating new memory, initializing by the value of a string. We're going to create a new short object using the primitive data type short. And we're also going to create a new integer object using the value of method. Now here's a performance tip. Classes and objects have some overhead associated with them. They offer generality at the cost of inconvenience in digging out the value. And there are some space costs as well. Here's an advanced performance tip. When the need arises to use your value as an object, use this method, value of, because it uses a pool of objects which for performance reasons is preferred over to allocating memory using the new object. Now let's take a look at atomic classes. With Java 5.0, additional wrapper classes were introduced in the Java util concurrent atomic package. These classes are mutable and cannot be used as a replacement for the regular wrapper classes. Instead, they provide atomic operations for addition, increment, and assignment. Atomic variables which can help us to write lock-free and wait-free algorithms which were not possible prior to Java 5.0. The atomic wrapper classes and their corresponding types: atomic integer, atomic long, atomic boolean, and atomic reference. We will discuss these atomic wrapper classes in greater detail in Chapter 12, Threads and Concurrency. Now let's run our program. This concludes our discussion of Java data types.